Do you have a background in pigeons? Have you had pigeons as a youth or?
Oh, absolutely not. No, no. Like I said, I was a city kid, and certainly there are certainly, all kinds of stories about, inner city pigeon lofts. I guess Mike Tyson would be the best known, having his loft on his roof, in Brooklyn. But no, I grew up, in the Bronx and Westchester in a called Mount Vernon, which is right next to the Bronx. This is basically the Bronx. But no, I didn't really get exposed to pigeons. I got exposed to pigeons as I began my research studying migratory birds. So the first navigation research that I did was in migratory birds. And it wasn't until after my PhD, when I moved to Europe, because I had a bunch of fellowships that I had there, that I kind of transitioned to pigeons. And the main motivation for me to kind of start working on pigeons was that they were experimental animals to actually look at how the brain enables their navigation ability. So my probably the most significant contribution that I've made to homing pigeon navigation research is uncovering some of the underlying brain mechanisms. Um, and I started doing that work in Italy, already 2 years after my PhD.
So you said that there was a loft at BGSU?
There was. Right.
Okay.
Yeah, I had a loft. So when I came to Bowling Green in 1989, a part of what I wanted to do was set up a pigeon loft, and part of my startup package. So when you're a university professor and they want you to do research, the university gives you a chunk of money to kind of set up your lab, and then they hope you keep it going with grants. And so I came to Bowling Green and I set up a functional experimental pigeon loft, and it was just great. Again, like I told you, I had a lot of help with the Toledo racers, the Toledo group. But what was interesting is because as navigation researchers, we're not so much interested in racing. We're interested in the development of their maps. And what was curious about Bowling Green from day one is that they just weren't particularly good at navigating. They were great racers, right? These guys train to the west and they come back and they do all the routine stuff. For me, it was fascinating because it said something a little bit about how these birds are able to build a map, because you've known Northwest Ohio. Right, basically in every direction, it's corn, soybean, and wheat. Right, so there's not a lot of heterogeneity. There's not a lot of stimulus heterogeneity. So what separates one place from another place? So Bowling Green, if you go to the north, there's the Toledo, there's the lake. There's some interesting stuff there. Bird could learn about that spatial information. But to the east, west, and south, it's all corn, soybean, and wheat. So they never did as well as they did in Italy, where I did a lot of work. So I gradually did more and more work in Italy as my research progressed. Because they're really good navigators there. You could take them anywhere. They'll come home.
Hello and welcome to the All About Pigeons podcast. I'm Phil.
I'm Chris.
And today we have with us distinguished research professor Dr. Vern Bingman. He's got his bachelor's in zoology with honors from the University of Wisconsin, Master of Science in Zoology at the University of New York, Albany, and his PhD in the zoology state of New York. Lots of publications on his research on the navigation and homing ability of the pigeon. And hopefully he can shed some light here on it and give us some good information that especially helps some of these guys who are doing racing and stuff like that. But it is a really curious thing. There's so many different theories. We were talking about this the other day. Smell. Pigeons can smell their way home. They can hear their way home. I've seen research where they've put contacts on them and proven that it's not a visual thing, that they can still get home with that. Right to the point with some of this, with all the research that you've done, what can you say has most weight when it comes to that?
That of course is the number one question,
right?
And what I could promise you, if you interviewed 10 homing pigeon researchers, you'd get 10 somewhat different answers to that question, right, about their navigation ability. So again, I just want to emphasize that there's a difference between how navigation researchers use homing pigeons and how racers use homing pigeons. Again, and the crucial distinction is that as racers, you guys typically train from a particular direction. So you could take birds, 200 miles away to a place they've never been to before, but they generally are trained to go west, right? Or east or some particular direction. So they don't really need to know where they are when they begin their return to their loft. And as researchers of homing and navigation, we're interested in their ability to come from any particular direction, right? So they're trained to the north, south, east, and west. Training is really designed to enable them to build kind of a global map of space that they can exploit. So the question you're asking is, how do you explain in an experimental context, how do you explain the remarkable ability of homing pigeons to figure out the direction home from a place they've never been to before, from say 50 kilometers or, 40 miles, 50 miles, 60 miles, maybe 100 miles. And again, this particular navigation ability that I'm talking about is not infinite, right? So you couldn't take a pigeon somewhere, the way we train our pigeons in the research, you couldn't take them 500 miles away and expect them to come back, right? Because they're not directionally trained. So again, so the upper limit for this kind of homing navigation ability might be 100 miles, depending on the kind of training that you give them. So as you've already pointed out, Phil, there's been a long-standing controversy about what is the sensory origin, if I can say that, or what kind of stimulus do these birds use to determine their location in space. Where am I, right? Particularly when they're taken to a place they've never been to before. And the controversy has basically revolved around whether the birds are using some kind of geomagnetic map, using predictable variation in the Earth's magnetic field to figure out where they are in relation to their home loft, or whether they can rely on variation in the distribution of atmospheric odors. In other words, they smell their way home, which is not what they do, but can they smell their location relative to where they want to get to? And I can tell you that I've been to conferences where the protagonists of the magnetic field hypothesis and the protagonists of the olfactory hypothesis have just really gone to blows. I mean, you would think it was like a prize fight. I mean, there's the sociology of this controversy is as interesting as the questions that they're trying to answer. And there are different research groups. All I can simply say is that based on my experience, the overwhelming evidence is that when you take a pigeon and you take it 40 miles away to a place it's never been to before, or 50 miles away where it's never been to before, it is able to figure out where it is relative to home, relying on olfactory cues or atmospheric odors. Again, it's a little bit counterintuitive, right? Because birds are not known to have a particularly good sense of smell, right? But nonetheless, I've been involved in a number of experiments with some brilliant researchers. Many of them are at the University of Pisa in Italy, where the best work on the olfactory map has taken place. And again, if you knock out their ability to smell, they don't get home. You plug up their, by either plugging up their nostrils, or you cut their olfactory nerve. You manipulate the kinds of odors they're exposed to, and they start going off in funny directions. And the evidence for a magnetic field map, okay, the evidence for a magnetic field map is not as strong. I mean, if you look at the research there, at least in my view, it's just not compelling. Now, there have been conversations, pigeons are very clever, they're opportunistic. So there's certainly a legitimate conversation about whether the type of information these birds use to navigate, to locate where they are relative to the home loft can vary depending on their location, right? So, the idea being that Italy, because of the topography and the sea and the distribution of odors, you could build a more reliable olfactory map. Where in contrast, if you're in Ithaca, New York, or if you're in Germany, maybe they're less reliant on odors because they're a less predictable source of information, right? And as I mentioned to you before, Phil, I've been involved in experiments where we've done these very simple olfactory manipulations. We've done them in Georgia, we've done them in Arizona, we've done them in Morocco. Wherever I've gone and I've manipulated the olfactory system, you see a real corruption in the ability of these birds to relocate home. So again, in my opinion, the evidence is compelling that when these birds are successful, and again, these are homing pigeons in an experimental context, not a racing context, they're able to locate their position in space relative to variation in the distribution of atmospheric odors. I just think it's compelling. Having said that, if you had an advocate talking to you about the magnetic map, you could perhaps make a persuasive case that all the olfactory evidence is like an artifact of some kind or another, and that it really is the magnetic field. I don't believe it. Again, I think I'm familiar enough with the evidence that there's no reason to actually believe that. But to be honest with your public, you could have someone on here talking about a magnetic map.
Wow, that's definitely, I definitely didn't think that was the way it was going to go. I mean, it just, because the common theory always is, it's always electromagnetic, but they're all theories. But I mean, like you're saying, you take away that sense and it messes them up. That's scientific right. Method right there, I guess.
Yeah, I'm absolutely convinced. Now, just again, for the sake of completeness, position fixing or map-like mechanisms, which in my opinion are based on olfactory information from distant sites, okay, they are then coupled with a compass sense, right? So in other words, think about a map and a compass. You look at your map and it tells you where you are and where you need to go. So you look at the map and you say, oh, I need to go south. But the map doesn't tell you where south is. And that's how homing pigeons are doing it. Okay, so they need to rely on something else to figure out now that the map tells me I need to go south, what do I use? Where is south? And this is where now there's, we've known this since the 1950s, and the sun stuff and the magnetic stuff since the 1970s probably. But the birds will rely on the sun and the Earth's magnetic field to define their direction in space as a compass, right? So the magnetic field is important, especially under cloudy conditions. They preferentially rely on the sun to go in a particular direction. So if the map says south, they'll use the sun to go south. But if it's cloudy, then they can rely on the Earth's magnetic field. So the Earth's magnetic field is part of the story, but it's not the map or the position fixing mechanism. So they rely on the magnetic field, not as, in my view, not as a map. And I think there's a universal consensus here, there's no controversy, that when these birds define directions in space, when they fly off in the direction that comes from the instructions from their navigational map, they can rely on the Earth's magnetic field and the sun, with the sun being preferred cue. But if you're in Germany on a cloudy day and the sun, you can't see the sun, they can rely on the Earth's magnetic field. But again, there's no big controversy there or not there. I also wanted to add one thing, if you don't mind. You mentioned that there's been some research where they've used translucent lenses on birds and see that some of them still get back. And that's kind of true, right? But if you look at that research, the vast majority of those birds that are carrying translucent lenses do not get back to their loft. A big deal has been made out of the one or two that get back, but the vast majority of the birds do not get back. And actually, most of the research that I've done has not looked so much at this long distance navigation based on what I would consider an olfactory map, but rather local navigation where the birds are relying on visual landmarks. The visual system and landscape features and landmarks are a big part of the navigational process, both, in my view, both for an experimental context and in a racing context. I mean, these birds are coming back. When you guys are racing birds from 500 miles away, 1,000 miles away, right, they go in a particular direction, but at some point they enter a region of familiarity. That's why you train them from 30, 40 miles, right? You want to build familiarity within that 30, 40 mile range. And when they're in that zone of familiarity, there is a transition to relying on visual cues. They're actually relying in part on a visual map, again, of landmarks and landscape features. And the reason why this is of particular interest to me, because the brain region that I study, which is called the hippocampus, that particular brain region you have as well as human beings. It's the hippocampus, for example, that you might be familiar with its role in memory. You might be familiar with its degeneration associated with Alzheimer's disease. Birds have the same hippocampus, right? And they get old and they start having problems too, by the way. But that's another story. So they do have a visual map, right? Very much like the human visual map. Okay, and they will use that in areas of familiarity near the loft, depending on their training. So again, when you guys are getting up at 6 in the morning and taking birds 30 miles away, the learning of that visual landscape that's going to separate winners from losers, okay, in addition to kind of train their motivation, right? So they have kind of two maps to find their positions in space. Olfactory map from distant, unfamiliar locations, and a visual map over, shorter distance and familiar places.
I get up at 6 in the morning to fly my birds.
Guys in Toledo do. All right.
I'm just kidding.
Yeah, especially when they're working. I know a lot of those guys worked at the G plant up at Toledo, and before they go on their shifts, they'll get up a couple hours before they have to go to work. Right? And they'll train their birds and they'll head to work.
Nice.
I fly mine before the sun comes up.
Yeah, no, especially in Phoenix, you got to.
Yeah, yes, sir. Well, right now we're a little short on daylight, so.
Yeah, well, it's not 7 or 8. Yeah, no, actually, to be honest, this is probably just on a side note, just out of curiosity. I just spent a week in the United Arab Emirates helping a friend of mine, set up a homing pigeon research lab there. And if you think it's hot in Phoenix, those guys for 4 months, they can't do anything. I mean, it's 130 degrees there in the middle of the Arabian desert, and they just shut down for 4 months. Nothing happens.
I take a hard pass on that.
Yeah.
Yeah. So this is kind of on what you were just saying. So this was a question from one of the listeners, from Stephen Eck. He said, Jonathan Hagstrom put forward an idea. Atmospheric propagation modeling indicates homing pigeons use loft-specific infrasonic map cues. That infrasound is a major player in their homing ability. And he wants to know, is this still a strong hypothesis? And is there anything loft owners can do to increase their chance of successfully returning home?
Yeah, okay, so we talked about the prevailing hypotheses of the Earth's magnetic field and the olfactory hypothesis. Hagstrom is kind of a renegade, for lack of a better term. He has been proposing now, probably for about 15, 20 years, that we are neglecting infrasound as a potential source of positional information that would enable homing pigeons to find their way home. And the sources of infrasound could be things like ocean waves or wind patterns through canyons and things that propagate a very long distance, right? So infrasounds tend to be relatively low frequency sounds, which are capable of propagating long distances without losing energy, right? Think about whales in the sea and stuff like that. So they could be kind of a landmark. All right, so that's the idea, and it's certainly plausible, right? It's certainly plausible. Okay, in my opinion, these sources of infrasound are not specific enough. Okay, if you think about an ocean, right, it's the whole, if you're in the Atlantic coast, the whole East Coast, it's the whole West Coast, right? So the sources of the sound, for lack of a better term, are not precisely localizable. So that makes them potentially only a crude source of positional information, right? Only a crude source. The consensus among the influential researchers in the field is that the infrasound story is unlikely to provide significant positional or map-like information for homing pigeons. But I like to view myself as being somewhat more objective. I like to view homing pigeons as being incredibly clever and opportunistic. So in situations where, for whatever reason, because they can detect it, right? So to be clear, they have the sensory capability of detecting these infrasounds. That's a fact. That's a point in favor of this infrasound idea. If infrasounds are important, I would argue that they could contribute to the homing success of pigeons. They can contribute to their navigational abilities, but they're not going to be a significant source of navigational information. That's just my opinion. And I guess the consensus among the influential researchers in the field is that, again, this is a flaky idea that maybe it's interesting, maybe it's not, but it's not part of the conversation like olfactory cues and geomagnetic cues. Having said that, in the context of racing, any kind of spatial heterogeneity, so again, I am not a racer, but there are two elements that contribute to the success of racing, in my opinion. One is navigation ability and one is motivation. And my guess is that there's a lot more variation in racing homing pigeons with respect to their motivation to return compared to the navigational ability. I think all birds are good navigators, and I think all homing pigeons are good navigators. So the difference between a winner or a loser is not so much going to be based on their navigation ability, but just how willing they are to get back. But anyway, that's a separate issue. Could playing with infrasounds, how could infrasounds help you win? Again, any kind of spatial heterogeneity, anything that makes one location different from another location with respect to the home should assist in the navigational process, right? It's going to help them better understand where they are in relation to their goal. But the challenge I would have is how could you manipulate infrasound? I mean, these are very peculiar sounds. Okay, so in a science fiction world, one could imagine you could build a source of infrasound at the loft that the birds might be able to detect from long distances.
I'll just play Metallica when we're racing.
There you go. Although that's still not quite, it's not as low a frequency as you'd like. I mean, these infrasounds are like, I don't remember exactly, to be honest with you, but it's on the order of 20, 30, 40 hertz, right? So it's stuff that you can't hear. You could feel it because it vibrates, right? But you can't really hear it. So again, just thinking in a science fiction world, if you wanted to play the infrasound game and give yourself an advantage over other racers, again, you could play Metallica, or you could just, put in a infrasound source at the loft, right? That the animals then could detect that might assist them in navigating to the loft. But since these birds are hearing this infrasound, would there be some negative consequence? What would be the amplitude? In other words, how strong should be that infrasound signal for it to be useful? Again, the beauty of infrasound is it propagates, right? It's not absorbed by objects in the environment. The energy isn't absorbed by the objects in the environment, so it propagates it stays loud over a long distance. And then you'd have to look at the physics of this, and I'm certainly no expert there. But again, if you're going to play with this, if you want to buy into this, just put an infrasound source next to your loft and see what happens.
Just play whale sounds all the time, and then when you release it,
something like that, yeah, something like that.
In the Racing Pigeon Digest, they were talking about, we're getting all these really big losses now from birds, and at first it was like, is it because of all the satellites? Is it because of the 5G? Or is it because of just the heightened solar activity? So they had a chart where all the different races happened, and it showed bird losses And the bird losses coincided with really highly active solar activity days too. What are your thoughts on that?
Okay, so this is actually interesting. This is also true of migratory birds, disorientation in migratory birds. So yeah, so this is one. So the evidence is real, and this is one piece of evidence that researchers that advocate for a geomagnetic map, a magnetic field map, would argue, because everything you talked about will corrupt, if you will, the natural geomagnetic field. So solar flares are associated with, again, these magnetic storms that will create funny magnetic fields, right?
The charging of the ionosphere.
Yeah, I mean, I don't really understand the physics of it. I simply know that you get these magnetic perturbations, right? And if the storms are really bad, communication systems start to collapse too. I mean, the great fears is massive solar storm that knocks out.
Or they get better in some cases.
Yep. Well, in principle, again, and again, I don't know much about cell phone towers and things like that, but I do know there's a body of research that argues that these cell phone towers produce a source of energy that will interfere with the local Earth's magnetic field. So the short answer is yes. In terms of losses and things like that, it would in fact be prudent on the part of racers, I think, to pay attention to solar activity. It is predictable, it is recorded, and when there's super high solar activity, you might think maybe twice about taking birds far away. You're not going to do much about cell phone towers. They're there. Again, and they're everywhere. You can't hide from them. But I would argue that, but I'm not going to buy the idea that this electromagnetic disturbance, whether it's natural from the sun or artificial by the various kinds of technologies that we're distributing around the world, is necessarily corrupting the map. Because like I mentioned, you could have an effect on their compass, in other words, the directional sense, which is also dependent on the Earth's magnetic field. In fact, the best, again, I'm a little bit out of my depth here, but certainly the prevailing hypothesis about how the birds detect the Earth's magnetic field in the context of a compass is that they use really a quantum phenomena. So this is actually, you have the light energy, there's light energy that hits the eyes and impacts the spins of electrons. So again, it's actually operating at the quantum level. And these disturbances that we're referring to, that you're talking about, all could impact these kind of electromagnetic interactions that are operational at the quantum scale. Whereas the best hypothesis, so if there is a magnetic map, the best hypothesis is that magnetic map would be based on these little pieces of iron, these magnetite. Those are, it's more of a mechanical system than an electrochemical system. Yeah, I like the way I just said that. And those would, and my understanding, and only by my understanding, would not be impacted by these various electric storms and things like that. People will use these real data to argue that, the map is electromagnetic. And I would say, no, it's not. There could be all kinds of these disturbances could have all kinds of diffuse effects on the nervous system. I mean, the nervous system is an is an electrical system. It's impacted by ambient electrical fields, right? So that could be part of it. There could be some generic effects. Also, you could be impacting the compass insofar as these animals are relying on their magnetic compass, that the magnetic compass is contributing to their behavior, their successful navigation, even when the sun is out. That's where I see that. But the short answer, too late, sorry. But the short answer is, yeah, it's real, and yeah, it's something that racers really should take into consideration if they want to minimize losses.
I found a race bird on one of the biggest solar flares of the cycle. Showed up in my place with about 30 others. That was from the California Classic race.
Well, okay. I didn't. So this was good news or bad news?
Well, they were supposed to go back home to San Diego, and they
okay, I see what you're saying. I didn't completely understand. So there's an example of that. Again, the phenomena is real. There's data from homing pigeons. There are data from migratory birds.
Did you ever observe any other types of pigeons other than homers or racers?
Observe in what sense?
Well, for instance, I just acquired a new roller pigeon. Usually I wait a week or so to try to settle him. I turned it loose in 72 hours. He's still here today. So I just curious if you ever did any research on other types of pigeons, breeds and whatnot.
I have not. So let me understand. So these rollers will home?
Oh yeah.
From the same kinds of distances as homers?
No. So we're talking more, they call it settling. And most of my rollers, actually probably all of them that I'm flying at this point, have been rehomed from other places. One place was about 2 hours north of me, and the other place was about 30 minutes south of me.
So they're not going back to their original homes?
No. If anything, I believe they would get lost if they didn't settle.
No, I've only worked with homing pigeons, but as a side note, which is kind of interesting. So again, I mentioned in passing this brain region called the hippocampus, which is absolutely crucial for this when they're relying on their visual map of space. And there's a group of neuroanatomists in Germany that looked at this hippocampus in homing pigeons compared to other races of pigeons, right? Other breeds of pigeons. And what they noticed is that the hippocampus is actually bigger in homing pigeons than in these other breeds of pigeons. So in the homers that are the supreme navigators, you have this brain region is larger, and presumably that facilitates them or assists them in navigating by visual landmarks. The other birds that are not particularly good homers don't have that large hippocampus, and therefore they're less good, for lack of a better term, at learning landmarks and visual landmarks and visual landscape features for navigation.
Gotcha. That's something I was always kind of curious about. So these rollers must have a memory like a goldfish.
Well, actually, I worked in a lab for a little while in Spain that studied goldfish. They're not so bad. Right?
Yeah, no, I was curious about that too, because with homers, you can get an old homer from somebody and put it in your breeding loft and have it breed, and sometimes they say, well, maybe after it has a baby or something, it'll stick around, but then at the same time, if that bird takes off, it's just going to go however far it is to go back home. Whereas there's some breeds that you can settle, like with rollers, you never do releases, you always just loft fly them essentially,
right?
And so I guess just through all that selective breeding, that part of the brain got smaller, where the other part that gets its roll got bigger, right. I guess.
But again, my guess is that the difference between, I know it's a nightmare, because sometimes when I need to get pigeons, I will settle them in my loft and try to keep them as breeders, and they get out, they're gone. I tell the students, in the old days, these guys get out, they're gone, forget it. They're gonna go back to we can get them back. They're just gonna go back to their original loft.
Okay.
But I think that speaks more to motivation than navigation, to be honest with you. What really motivates these animals is that during the first 6 months of life, they develop a faithfulness, a real fidelity, a love, if you will, of their home loft, and they'll work to get there.
How long do they remember where their loft is?
Oh, I think they'll remember it for their lifespan. I mean, I haven't studied that specifically, but I think that's as long-term a memory as a bird can possibly have. I would be very comfortable with the idea if you took a homing pigeon, trained it up, had it learn a map at the age of 1, and then you kept it in the loft healthy, for 6 years, and then took it out. You shouldn't take it 300 miles away, but if you took it out and took it 30, 40 miles away, it would get back. I'd be willing to bet on that. Just in my opinion, these are lifespan memories.
I was going to say, have you done any research with motivation, like widowhood or anything like that?
No, I have not. I just remember when I talked to the racers up in Toledo, it was always enjoyable listening, because everyone has their own little superstition about how they can motivate these birds and stuff like that. And I know widowhood is a very popular technique, but since not everyone uses it, I wonder how good it really is. One kind of little humorous anecdote is one of these racers up in Toledo, a guy named George Pruss, who was just absolutely, did all kinds of things for me. He actually played around with marijuana with these pigeons, right? He was feeding them marijuana seeds, even though there's no THC, there's no active substance in THC. He was hoping to get the pigeons the munchies on their way, but they'd feel so hungry that they would fly faster home and stuff like that. And I can imagine there are all kinds of tales that the racers have, and how they just try to tweak the motivation of these animals just to get a little bit of an advantage over the next guy.
That dude was ambitious.
Yeah, it didn't work.
He certainly couldn't have been a stoner. That's all I say about that.
Well, I don't know. I mean, like I say, maybe he knew that there was nothing in the seeds. They just had them laying around, but what do I know?
Yeah, I was talking to a guy the other day who does widowhood, and he says right before he takes the bird out, so he'll put another cockbird in there with that hen. So the last thing that cockbird sees is another boy bird in there with his woman. So he's really motivated to get back quick before anything goes down.
Does it work?
I mean, he that's what he does. So he must have some results with it.
Yeah. Well, again, I'm familiar with all these kinds of little tricks. The eye thing, the eye color. You guys are very sensitive to eye color. Have these like almost mystics that could look at the eye and tell you if it's a good bird or a bad bird or this or that. And I can't just for what it's worth. Even these Arab racers that I met when I was in the United Arab Emirates, they have these same. Everyone looks at the eye and they say, "Oh, this is this and this is that." So it doesn't really matter on culture, right? There are all these legends, if you will.
Me and Chris got told about a way to determine the sex of a bird was by swinging a magnet over their head, and if it goes in a circle, it's a hen or whatever, and if it goes straight back and forth, because they said it had a magnet inside of its brain.
I would be suspicious.
You never found a magnet inside of the hippocampus?
No, never. Like I said, there's these little pieces of magnetite, but there's no difference between males and females with these little pieces of magnetite. So no, like I said, I would be very suspicious.
Did you ever have? So I'm assuming since you traveled around a little bit, you had different groups of birds. Did you ever have any that were better than most?
Okay, so that's a great question, right? So I've had familiarity with bird, so we're talking about experimental homing pigeons, not racing pigeons. Okay.
Right.
All right. And what I can promise you is that the performance of the birds in Pisa, Italy, are vastly better than any other experimental group in the world. So again, there are big pigeon lofts. So there's big, much bigger than anything I've ever had at Cornell in Ithaca, New York, Frankfurt, Germany, near Munich, Germany, Tübingen in Germany, and then Pisa. Those were the four big lofts. The birds in Italy vastly outperform. They're faster. They come back from any particular direction. And of course, this generated a lot of curiosity. The question was, are these genetic differences? Are these breeding differences? Or it has to do with the availability, some environmental variable that presumably makes it easier to navigate in Italy. So they did some experiments where they took birds that were born in Germany, but then they were moved when they were very young, a month old, 2 months old, they were moved to Italy, and similar Italian birds were moved to Germany. So you were controlling for genetic composition and you're changing the environment. And what they found is that the German birds, when they're in Italy, they do great. And the Italian birds, when they're in Germany, they do just as bad as the German birds. So the variation in terms of these, again, in terms of these experimental laws, the variation explained not by the genetic composition of the birds. They seem to be relatively genetically, I wouldn't say homogeneous, but you have the same amount of variation in these different populations. Again, Ithaca, Tübingen, Munich, Frankfurt, Pisa. But if the pigeons are growing up in Pisa and they have the Mediterranean Sea, 10 kilometers from their loft, and you have these mountain ranges and these river valleys, they just do fabulously.
As I gathered it, you were using locally sourced birds for each.
Yep. Okay. When I'm working abroad, I am working with people that it's their lofts. They're not mine. I'm working with other people, but these are all locally sourced. They breed themselves. Okay. Sure. Most of the birds are being bred by these research labs. So Ithaca had their own breeding loft. Frankfurt had their own breeding loft. Pisa has its own breeding loft. So these are all local birds. But like I said, you could take those birds that are 50th generation Italian birds, and then train them up in Germany. They're not particularly good. But if you take those German, you take German birds that are 50 generations of German birds and take them to Italy, they'll do great. Right. So again, it's about, from a navigational perspective, explaining variation, explaining differences in different groups of pigeons. The main difference is, how, in my view, how heterogeneous and stable are the spatial cues in the environment. Like I said, Bowling Green, they're terrible. Came to Bowling Green, I was so excited. I take these birds 40 miles away. I take them days to come back. I guess, what's this all about?
Did you ever do anything in Belgium?
No.
With Belgian birds?
No, but I do understand that they're the best. They're the thoroughbreds of the pigeon community. In fact, these Arab guys that I was hanging out with.
That's a lifestyle for them.
Yeah, it is, and it's still active. The nice thing about it is still very active. Again, and I may be exaggerating here, but I heard stories about some of these Arab guys, going to Belgium and buying birds for $10,000 and this and that, and I go, whoa!
Oh, they spend a lot of money on them.
Yeah,
yeah. Check out these auctions, these race auctions and things. A lot of those birds that Ryan brings back from Belgium, they go for thousands of dollars.
Yeah, no, there's a market there. Again, there's still a high end there's still a high-end market for these thoroughbreds, these secretariats, right? Or these, these animals that come from winning stock, for lack of a better term. And clearly, again, I'm not a racer, but I certainly am familiar with Belgium being the Kentucky, for lack of a better term, of the homing pigeon world.
And those guys purchase land they'll buy a piece of land just so that their loft can sit in a certain position and face a certain way.
They probably know which way the winds are blowing and things like that.
Yep.
For sure.
Oh yeah. Yep. They talk about all that kind of stuff, and it's a big thing. What else you got there, Phil?
Well, those are the questions from the listeners. This has been awesome. I feel like that last part you just talked about, how bringing different birds to Italy and then bringing the Italian birds to Germany, and that it just seems like it's that area that got me thinking about the locations of some of these big one loft races. How sometimes why does this one loft race have a lot more losses than this one over here? Or now that's really interesting.
So you wouldn't say different horses for different courses. You just say that one course is better than another.
Oh, okay. Oh, you see some mudders and turf versus whatever, sand, whatever it is.
Long distance, short distance, and so on. You'd prefer to believe that locations, one course would be better than another.
I think homing pigeons will perform better in some places compared to other places. There's an issue of scale here that I think is worth mentioning in passing, right? So Germany is a long way from Italy. Ithaca, New York is a long way from Germany, right? These are very different geographic regions. I think what you guys are more interested in is whether within a local space, so within the Phoenix Club or within the Northwest Arizona Club, might there be local variation that would lead some pigeons to outperform other pigeons? Okay, and that's a different question, right? You see the challenge here in terms of spatial scale, right?
Sure.
Is North Phoenix going to be easier or harder than South Phoenix, right? Is North Flagstaff going to be easier or harder than South Flagstaff? I don't really know if I can give you an informed answer, other than to once again emphasize that the crucial element is the availability of environmental information. Like I said, discrete landmarks, landscape features. These birds, certainly the homing birds, like to follow roads, right? So roads that are aligned with the path home will facilitate homing. Certainly, again, in an experimental context. I don't know about racers, right? But we know we've tracked these birds. We put little transmitters on them, GPS transmitters on them, so we're able to follow them around.
Do they follow waterways?
They will follow canals. Certainly in Italy, you can see them following canals. Okay. I don't know that much about rivers because it depends if it's straight or winding, right? But they like linear features. They like to follow linear features, and there has to be a reason for that. I'm not sure what that is. I'm very confident talking about these large-scale geographic variations in the performance of pigeons. I'm less certain about local variation because the birds are being exposed to the same kind of things, right? They're all seeing the same highways, the same mountain ranges and stuff like that. Having said all of that, there's a message that can generalize from homing pigeons in the experimental context to the racing context, is that exposing them, having a loft that's exposed to atmospheric odors so these animals can learn which odor profiles are associated with winds from different directions, can only help. It's not going to hurt, and it could potentially help their navigation ability.
Oh, for instance, the sun cage on top of the loft where they
absolutely. Yeah. Like I said, I can't promise you it's going to help or not help because, again, I think a lot of the variation in the context of racing is going to be more motivational than navigational. But the bigger the navigation, but the bigger the navigational toolbox, you just want, the idea would be to make as much spatial information available, which is why, we talked about this, putting an infrasound source on the top of the loft. It seems like a crazy idea, but it's not going to hurt necessarily unless it's too loud, but it could potentially help because it creates this spatial heterogeneity. And that for me is crucial.
I think a guy could probably get away with just setting that sound off, say, during feeding time. And then when they're out on a release, you could set it off.
Right. And what you're saying there probably follows nicely from what Ed Wasserman talked with you guys about. It's a conditioning cue, right? If you associate the infrasound with the food, right, or just like the piece of paper, right? And if their motivation is tied to hunger, then from a long distance, they may hear that same infrasound, and that may in fact not only enhance their navigation ability by providing a beacon that they could potentially assist in reaching the home loft, but it also then could be a conditioning cue that motivates the search for food or the expectation of food. So, wow,
Sure.
there's food, I'm going. Well, you know, let's
Got that from my buddy Pavlov.
There you go. Exactly, that's what it is. That's exactly what it is. It's what psychologists call Pavlovian conditioning.
For sure.
Yeah.
Well, I think I'm going to put some empty bottles up on top of my roof and see if that wind can blow a little bit of noise every now and then.
There you go.
Any little thing, right?
Yep.
Well, we're definitely coming up on the clock. Sorry, we're a little bit over here, but it's been great talking with you. You've definitely given us
this is
great
enjoyable.
information.
I have great fondness for you racing guys. I mean, I've had great experiences chatting with people in Toledo, and even, you know, and just again recently I was chatting with these racers in the United Arab Emirates, and I was reminded about just how interesting these guys are, right? The people that do the racing, their commitment, the joy that they have, the commitment. Yeah, no, you guys are special people, so it's always a pleasure talking to you.
Wow, this has been great. Thanks for coming on. Really appreciate your time.
And, you know, thanks for giving me the opportunity to have an interesting conversation on a Tuesday night.
Oh, yeah, this has been great. Thanks so much.
Okay, best of luck to both of you.